So we have captured the complete supervised machine learning process in 3 steps. So let's expand each step, and then if you expand each these 3 steps, then we can make this into 10 steps. So that's what we'll be doing. So you see that data loading and data cleaning, EDA, feature engineering, data splitting, step 5, then model creation, then model training, model testing, model evaluation, model optimization. These are the 10 steps. The 3-step process has been expanded into 10-step process. Okay, so if you put it in 3 steps, it's just data acquisition, pre-processing, and model building and evaluation. So this 3-step process has been expanded into 10 step, and let's discuss in detail about this 10-step 10-step supervised machine learning process. So a 10-step supervised machine learning process is designed to guide the journey from raw data to a well-performing model. So here is a detailed explanation of each step, emphasizing the iterative nature of the process and and my infographic animations ability to enhance understanding. So let's begin with the step 1. So step 1 is data acquisition. In this step, we gather raw data from various sources such as databases, APIs, or files. So here we can see on the screen that so these sources such as databases, APIs, and files uh, tell you the process of collecting the data, highlighting the diversity and volume of data that we are going to working with. So once data acquisition is done, next we will be moving on to the data cleaning. So data cleaning is nothing but the clean the data that has been acquired. So here in step 2, data cleaning, what we'll be doing is we will clean the acquired data by handling missing values, outliers, and inconsistencies. So here in step 2, we will be looking into the step 2 in detail. So we will be discussing about various techniques that can be used in handling missing values, outliers, inconsistencies, and we'll work on various practical examples with animations. My animations could show you how data points are checked, flagged, and treated, making the process of data cleaning more relatable to you guys. Then we will move on to the step 3. Step 3 is nothing but the exploratory data analysis. So we will conduct an exploratory data analysis, EDA, to understand the data's characteristics, distributions, and potential patterns. So in step 3, we will be using the complete descriptive statistics, a lot of statistical concepts to understand about the data. So mainly my animations in this course and infographics in course could animate the data visualizations that uncover insights like histograms, scatter plots, and correlation matrices. So with this, data acquisition is successful, data cleaning is fantastic. Then we moved on to the EDA. So we got the proper understanding about our data. So now it's time to move on to the most important step, which is feature engineering. Create new features or modify existing ones to enhance the predictive power of your model. So feature engineering is nothing but the engineering the features out of raw variables. That's what is engineering. You convert a raw material into a finished product. So that process of designing, modeling, and manufacturing and producing and using a mathematics, what we call it as an engineering. Here also we take a raw material and then we design it. We then we perform some algorithm calculations on top of it, and then we engineer that raw material into finished product is nothing but a feature. So that's why we call it as a feature engineering. So I will be using a lot of infographics and animations. So my animations will depict the transformation of features such as encoding categorical variables, creating interaction terms. Basically, I will be putting feature selection. I will be using feature selection methods and feature extraction techniques. All the algorithms which are related to that, I will be explaining in detail. Then we will move on to the step 5, which is data splitting. Of course, this 10-step process is absolutely specific to supervised machine learning process only. It is not even applicable to supervised deep learning. It's only specific to the supervised machine learning. And this process is not applicable to unsupervised machine learning also. It is not applicable to reinforcement machine learning also, reinforcement also. So it's only applicable to the supervised machine learning process. You have to be very clear. I'm very clear. You should be very clear. So the step 5 is data splitting. So split the data set into training, validation, and test sets. So the animations could visualize how the data is divided, emphasizing the importance of each subset in training, tuning, and evaluating the model. So then we will move on to the step 6, which is basically model creation. So model object creation. So here this step is what we will do here is we will import the respective model class. Once you import the respective model class, then we have to instantiate the object from the class. In a simple term, we'll create an instance from the class. So that's what we will do. So then after that, we'll be moving on to the model training. So model training is nothing but, as in our previous case in step 6, we have created a model object. We have created an object. So now we will be calling a fit method from the respective object, and we'll provide a training data set like x underscore train comma y underscore train. So with that, the model will be trained with the respective data. So we'll fit the data into the model. So that's using a fit method, fit method. So once the model training is done, so train the model on the training set using the optimized hyperparameters. So the animation could my animations or infographics could illustrate how the model learns from the data, gradually improving its ability to make predictions. Then we will be moving on to the model testing. So evaluate the model's performance on the validation on the test set, basically here, because in data splitting we'll be splitting the data into try and test set. So we will evaluate the model's performance on the test set. So in step 7, I will be explaining model testing for each and every algorithm with specific to the task. The algorithms which belongs to a regression task, and the algorithms which will be used to execute the classification task, and the algorithms which will be used to execute the time series prediction task. Even in step 6 also, I will be explaining and I will be creating an instance of each and every type of algorithm which are on in specific to the regression task. I will be creating instances or objects of each and every algorithm that will be used to work on a regression task and classification task and time series prediction task. Okay, so that's what we'll be doing in step 6, step 7, step 8. So then once that is done, so we will be moving on to the model evaluation. That's step 9. So in step 9, we will assess the model's performance using various evaluation metrics. Base again, and model evaluation metrics, I have split it into the five section. So first, we will be looking into the regression task evaluation metrics, and then classification task evaluation metrics. Then we'll be looking into the time series prediction task evaluation metrics. Then we'll be looking into the underfitting and overfitting analysis, learning curve, validation curve. Then we'll be looking into the trade-off a bias variance or trade-off, where we'll be doing bias variance or trade-off using bias variance decomposition, learning curve, and validation curve. So with that, we'll be doing a proper model evaluation. Then we will be moving on to the so it moving on to the last step, which is the model optimization. So step 10 is the model optimization. So based on the various results, further optimize the model if necessary. So my animations could show the iterative loop where adjustments are made to improve the model's performance. So if you look into this completely, so this is a 10-step process. If I just want to sum it up in few sentences, so this is how we actually work in real world scenarios. So all the newbies of data science, I would request you to attentively listen to me, because let's take a simple example of a project. If any new project comes to us, so the first step we'll be executing the data acquisition step. We'll find out where all the locations we can get the data of the respective project. We'll bring the data and we'll put it into the local machine. Okay, then we'll start doing data cleaning, then EDA, then feature engineering, then data splitting, then the most important one comes. So here, first what we'll do is we will go with a simple base model. In data science, we call this as a base model. What we call it as a base model. So if it is a regression task, the base model that we take is a linear regression. If it is a classification task, the base model that we take is a logistic regression. If it is a time series prediction, the base model we'll take is, I'm talking with respect to the machine learning only, not deep learning. That is supervised machine learning only. If it is a time series prediction, we may go with ARIMA or SERIMA. So these are the base models. So that's what we'll be doing here. In step 6, we'll create an instance of base model. So our uh, that's where our work creating an instance starts. That's where our step 6 starts. We will always start with the base model. So once the base model is created, so we'll do the model training for the base model, then model testing for the base model, then model evaluation for the base model, then we'll try to optimize the base model. One iteration is done, then the next iteration, what we'll do is we'll do the we will okay, we got some amount of performance from this. So now we want to check for different other models. Then I will take one more model. So for that model, if it required to be done a feature engineering again, if it is required to do feature engineering again, then I will do the feature engineering again, then I'll data split, then again I'll apply a new model. I'll create a instance of the new model here, then model training, model testing, model evaluation, model optimization. Then I will perform the results of base model and the new model. I will check which one is better. So now it's not at over. It's not at over, my friend. So then I will try with another model again. I'll to create another instance again. I will see. Okay, is there any do is it required to do any changes in feature engineering? If it is required, again I have to repeat the steps again. Fourth model, fifth model, sixth model, seventh model, then we'll compare the performance of each and every model, then we'll see whichever works better. So that's what we'll be going with, and this is what is called an actual supervised machine learning process in real world scenario. This is how we work, my friend. I hope you got it well. So that's the reason I have created a logical infographic from my experience. It came out of my straight out of my experience. You won't find anything this sort anywhere in internet, because there you'll see, okay, some random 5 6 steps of supervised machine learning process, but this is how it actually works. Okay, 7 to 8 years of work experience has been put into one infographic, and this is what comes out, my friend. So the iterative nature of a supervised machine learning process is a critical aspect to highlight. So let's break down how this cycle works, and how my infographic animation can enhance the understanding of supervised machine learning process. So the initial model creation, the first steps, the step 5 to step 9. So we will start with here. You see that we'll start with initial data set. We'll start with initial data set, then data cleaning, EDA, feature engineering, all done. Now step 5 we have reached. So here we'll split it into training and validation and test sets. So the model is trained on the training set and evaluated on the validation set using a specific evaluation metrics. So then, so after that, we will be moving on to the next step. Okay, so we'll be coming to the model creation, model training, model testing, and model evaluation. And after that, we'll be getting into the model optimization. So after refining the model, you evaluate it again on the validation set or test set. So this cycle continues until you achieve a satisfactory level of performance. So this infographic can show this repeated process. So with each iteration making the model better aligned with our goals. So that's the reason I just want to emphasize the dynamic process, how this infographic animation helps you to understand better about supervised machine learning process. So few points I just want to highlight. So this is not a linear process. Okay, supervised machine learning process is not just a linear process, it's a cyclical process, it's a iterative process. You have to keep in your mind. So cycling loops, you can see that from step 4, from step 4, which is feature engineering, to step 10, it will loop back to step 4 again and again. So this loop reinforces that it's not a linear process, it's about continuous improvement. Then so visualization of adjustments. So for instance, when you update features or hyperparameters, the animation can visually show these changes and their impact on the model performance. So then this is how the overall process works. So this infographic basically highlights and emphasizes the actual real world supervised machine learning process. Okay, it is an iterative process. So every time it will be repeated from step 4 to step 10, but sometimes you might have to get into the eda also. So for some models you have to do minute changes in your eda. You want to get more information about the eda with respect to the model, then you may have to repeat the eda also. But normally if you want to generalize the supervised machine learning process, then from step 4 to step 10 is a repetitive process, or else of some are other cases you will have EDA. By using this infographic animation, I think you got a clear cut understanding about supervised machine learning process. So I would request you to stay with me to explore and enter into the universe of supervised machine learning process. Welcome, my friends.